the ocean can be separated into separate layers, and we actually separate those layers of the ocean by their density. And so density, if you remember from earlier in this unit, is the mass of a substance in a given volume. So usually we measure that in grams per cubic centimeter. So pure water's density of pure water, if it was fresh water, its density would be 1 gram per cubic centimeter, whereas saltwater's density is 1.027 grams per cubic centimeter. So the density of saltwater is greater than fresh water. And that's because the density of water will increase when you add salinity to it. And so when you add salt to water, it increases. And then the density also increases when the temperature decreases, so as the water gets colder. So the layers of the ocean are arranged in such a way that the warmer, less dense water sits on top of the colder, more dense water. And you can actually kind of see that with this chart right here. It's called the TSD chart, temperature, salinity, density. And along the bottom, you can see the different salinities of the water expressed in parts per thousand. And then along this side, you can see the temperature in degrees Celsius. So the curved lines represent the density of the water. So if we look at water that is 35 parts per thousand, okay, and it is 15 degrees Celsius, the way that we can figure out the density of that water is if we follow this line up, okay, and then we follow the 15 degrees over, okay, and so the density of that water is going to be about right between 1.025 and 1.026 grams per cubic centimeter. So you can use this TSD chart to tell the densities of water. And you can look and see if you go to colder water, less salty water down here at 33 parts per thousand and warmer water up here at like 20 degrees, if you follow those, the density of that water is going to be 1.024 approximately grams per cubic centimeter, whereas the saltier, the colder water is going to be 1.028 grams per cubic centimeter. So it'll be much more dense if it's colder and saltier. So the ocean will actually separate into layers based on these different densities. And the top layer of the water is going to be down from the very surface down to about 100 meters. And that top layer of water is going to be warmed by solar radiation, and it's going to be very well mixed because that's where the waves are, that's where the currents are. That top layer of water will be, relative to the rest of the ocean, very well mixed and warm. After about 100 meters, which is about 333 feet, you get to this part of the ocean between 100 and 1,000 meters where the thermocline occurs. So if you remember, thermoclines are a rapid change in temperature with depth. So between 100 and 1,000 meters, you get a drastically dropping temperature. And that's because you reach a point where the sunlight doesn't really affect the water in the ocean anymore because it can't penetrate to that depth. So you get decreasing temperatures very, very rapidly, which means you increase in density. The halocline is also going to occur here, which is the rapid increase in salinity with depth, and the pycnocline will also occur here between 100 and 1,000 meters. And the pycnocline is a rapid change in density with depth. So the thermocline and the halocline overlap and create the pycnocline. And so you get the 100 to 1,000 meters where it will be very rapidly changing in temperature, salinity, and density as you go down. And then below that, the layer below that is going to be very cold, very salty, and very dense compared to the rest of the water. So here you have your top surface layer, okay? That's going to be around 20 degrees Celsius, got lots of mixing by waves and currents, and then after that, between 100 to 1,000 meters, okay, then you're going to have the thermocline, the pycnocline, and the halocline. And then below that, you're going to have very, very cold, very, very dense water. So anywhere between 3 and 5 degrees Celsius is what you'll see underneath that. This picture is a little bit deceiving because this last layer down here, this layer is going to be very, very deep. It's going to comprise most of the ocean. So it's not equal like this. So this will be a little bit long or a bigger layer than this top layer, and then this layer down here can be miles deep. So it's a little bit misleading. But those are the characteristic layers of the ocean.